All right. Welcome, everyone. Want to welcome you all to our demo day. My name is Aurelian. I'm one of the co-founders of Eskwelabs, and I'm very proud to welcome you all to our students' final demo day. So Eskwelabs started 2 years ago, and since then we've been working on providing data science education that is accessible, exciting, and effective for our learners. We are an online data upskilling school based in Manila, and our mission is to democratize the future of work through data skills and education. Today's event is a part of a series of demo days, which will showcase the work of our data science fellows who completed a 12-week part-time program to launch their careers in data science. The fellowship is not just about skills building. It is also a community that's curious about how to use data to advance innovation and impact, and many of our fellows will go on to work in industry. In fact, through new interview guarantee partnerships that we have introduced this year with this cohort, fellows can choose to have guaranteed interviews at innovative companies like QuadX, Home Credit, Kumu, and many more. But before they arrive at that future, they are going back to one of the reasons they wanted to learn data in the first place, which is to build a world that works. If there's something that you want to ask as you see our fellows present the many projects that they have built to tackle some pressing concerns and questions in our world, please feel free to head on over to the Dory link that was sent in the chat earlier to send in your questions for the fellows, which we will get to answer during our panel discussions. This demo day, we are reimagining the future with data, where we envision how data will be a big part of our future lives through innovations in the startup ecosystem, through better governance and policy, and the stock market, all through projects which provide a unique Philippines context. Now, before we get started, I have the honor of making a string of introductions. As they say, it takes a village to raise a child, and it definitely takes a whole community to create budding data scientists. So let me first introduce you to our star instructor, who will also be our moderator for this event. Welcome to Bash. Albert Bash Yumol specializes in data, its architecture, its analytics, and its human aspect. Bash is an education team lead at Eskwelabs. He believes in the potential of technology for advancing social good and impact, and is in many ways the embodiment of what we see as a perfect instructor for our fellows. Bash is a data practitioner, a data activist, a data instructor, and someone who can really look at data with a holistic mindset and a view towards making the world a better place, not just a slightly more profitable place for some companies. And that's exactly the kind of data scientist that we want to produce here at Eskwelabs. Next, I want to introduce some of our friends from the industry who will be providing feedback for the project and who will be acting as our guest judges on this panel. So first, I want to introduce Inigo Benavides of Gcash. Inigo joined Gcash as the company's first data scientist in 2017. He and his team pioneered G-Score, which is a credit scoring model behind G-Credit, which to date has brought financial inclusion to close to 1 million Filipinos with nearly 10 billion pesos dispersed. Since then, he's grown a team of 20 data scientists and engineers tackling some of the biggest data fintech problems you can imagine, like fraud detection systems, recommender systems, pricing optimization models. He's graduated from UP's first batch of professional masters in data science, researching entity resolution models with applications in fraud detection. Our second very esteemed judge is Michelle Alarcon of Z-Lift Solutions, an analytics practitioner since 1999. Michelle founded the analytics consulting firm Z-Lift Solutions in 2013 to enable organizations in analytics. She has also organized the R users group of the Philippines in the same year, a tech community which continues to meet every month up to this day for one of data science's most popular programming languages, R. She has always been an advocate of analytics for the masses, and in 2017, she joined the Analytics Association of the Philippines as the board of trustees to help develop the ecosystem and upskill the entire country in these core skills of analytics. And Michelle is an alum of UP with a degree in statistics and is currently teaching in UP's Professional Masters in Data Science and Analytics program, which I can see is very well represented on this panel. Michelle is also a co-founder and the head of learning at For the Women Foundation, which is a non-profit organization that provides free training in data science education to underprivileged women. And last and definitely least impressively is myself. I'm Aurelian. I'm one of the co-founders of Eskwelabs, and I work directly with our instructors and course facilitators to make sure that we have an exciting experience for our learners. But in a previous life, I was actually the one who gets to hang out with the data scientists and ask them how their models are actually going to make impact. I was previously a management consultant focused on education and employment topics in different countries around the world, where we did a lot of strategic analysis and economic research, and where I got to see some of the sides of how the business world interacts with the data science world. So those are the three of us who will provide feedback. We will be looking forward to seeing who on this judging panel is more likely to be the Simon Cowell of the group. But looking forward to a fun and an entertaining and exciting and interesting and educational experience. What's unique with the capstone projects that the students will be showcasing today is that they will represent a very exciting innovation in the startup ecosystem at this very moment, which is something that Eskwelabs is very dedicated to. So to help us set the context for the first project that's going to be presented, we have invited Digest, which is a legal tech company that the fellows have been directly working with for their project. And so with us today, we have Jay, the co-founder and CTO of Digest, alongside with Duke, lead developer. With the slogan of Law Made Easy, Digest is a legal technology platform that is committed to modernizing the Philippine legal system. Definitely a big task and a very important one. So I want to give a big welcome to Jay Akab and Duke Punzalan of Digest.
Good evening, fellows. Good evening, everyone. Let me share my screen for. Okay, give me a while. Okay. Okay, can you see my screen, guys?
Yes, yes.
Okay, thanks, Duke. Okay. Good evening, fellows. Good evening, instructors, panelists, and good evening, guests. Thank you for the introduction, Aurelian. It's a privilege to present for our company. We are Digest. We are a legal technology startup. Our main goal is to make law easy for everyone. Okay. Let me start with this quote from Derek Bach, the former president of Harvard University. There's far too much law for those who can afford it and far too little for those who cannot. So most Filipinos do not have affordable access to legal help or don't know where to go when they need when they need to. So if you look closely at the statistics, almost 35% of Filipinos experience a legal problem in the past 2 years. Only 20% of those were able to access legal help, and it took an average of 7 months to solve the problem. And in the end, only 62% were satisfied with the process. You see, law is a highly fragmented industry with no household name yet, unlike, for example, Jollibee for food, Grab for transportation, or SM for retail. Our current providers are the law firms. These law firms do not leverage the legal technology to provide better experience for Filipino clients. So we thought, what if we can find a way to improve these numbers? We focused on making three major things open and accessible. Basically, turning Digest into a one-stop shop for everything law in the Philippines. So our first offering is the lawyer marketplace, where people can connect with lawyers and get legal help based on their budget. Through our platform, users can find a lawyer and track their progress. On the other hand, lawyers can find which cases to take on. This makes legal services more affordable as clients pay the lawyers directly rather than paying the law firms who charge by the hour. So our second offering is the contract generation system, where where people could generate legal documents. Uh, yeah, users just need to fill in their information, and the system will guide them until the document is complete. For example, our most popular one is the freelancer contract, where you just need to fill in the relevant details for the freelancer and the client. You can even sign the document digitally within our platform. Okay. So our third product, and I think the most complicated one, is the legal research. Uh, this is where law students and lawyers can research laws and old cases called decisions. Here we collected over 60,000 decisions and almost 8,000 laws in the Philippines. And we presented it in a way that even non-lawyers can understand. So for example, if someone searches for a general term like civil, the platform should turn out all civil cases without much trouble. So that's where we needed machine learning. At first, we considered we considered manually tagging the cases in our CMS, but given the sheer volume of our data, we knew it would take time. So fortunately, we were able to collaborate with Eskwelabs, and we are super grateful for the generosity. With the help of Eskwelabs, we are able to provide a better platform to those who want to study law. So, okay. So at this point, I would like to call on our lead developer, Lupon Salan, to show you a small preview of how we integrated that in the backend.
Okay, thank you, Sir Jay. Eskwelab helped us to build the Philippine first AI-powered legal research, where we can classify by batch and we can classify by individual cases. Okay, next slide. As soon as we receive the API from Eskwelabs, we immediately consume and integrate it in our CMS. Integrating the endpoint is not that hard. It went smoothly without errors. Shout out to Caleb and Julia for making it sure it is straightforward to use. And if if the predictions of the AI matches our criteria, we filter it on our back end and show it to the end user. And as you can see in the pics, then classified data involves tagging to make it easily searchable and having categorized cases, and helps the end user related laws, which makes studying law easier.
Okay, cool. Thank you, Duke, for presenting and taking time out of coding. I know you're busy. Duke is in charge of our entire backend and third-party integration, and he just showed us how easy the integration went. So I would like to take the opportunity to give a shout out to our other developer as well, Ron Agreement, and our UI UX designer, Jill Caterina. We plan on releasing the next version of our site by the end of the month, together with the improved model that our fellows worked on this past few weeks. So I would like to commend them for their hard work and dedication as well. So yeah, so moving forward, our next step after this is we want to make the model smarter each time we make an entry from our CMS. So we have a lot of plans, and we encourage fellows to help us in our goal of providing Filipinos a better platform to understand law. So that's it. Without further ado, it's my honor to introduce Bianca Ben CEO, Macho Chan, Fidel Racines, Jay Silverio, Romeo Ben, Manangu, to present digestion. Let us give them a round of applause.
Hi everyone! We are proud to present our capstone project, Digestion, our text classification of Philippine Supreme Court decisions on criminal cases for Digest. Digest is a legal tech startup that aims to help businesses and individuals with their legal needs through easy access to lawyers, contracts, and laws. Legal research is integral to Digest's business model, and this involves sifting through cases to be used in court pleadings or providing advice to clients. And these cases and Supreme Court decisions are not classified, which brings us to the problem we data science fellows wanted to solve. With thousands of Supreme Court decisions categorically unlabeled, how can we use data science tools to save time for these lawyers? So instead of tediously looking through Google for relevant cases, they can spend time refining their case. The tagline of Digest is, "We make law easy." We aim to make law easier for our lawyers by building a classification model that uses categories to identify and distinguish Supreme Court criminal decisions.
Now for the limitations. Our first limitation is we only classified criminal cases. Our second limitation is we had only limited computational resources because we could only use what we had and some online resources. And lastly, we lack the domain knowledge and law practice because none of us are practicing lawyers. For our methodology, we first got the raw text data from the cases and attached them to the level 1 labels. We then did data wrangling, tokenization, and lemmatization. We then, using the now wrangled data, we did EDA and feature engineering. And that resulted in labeling, modeling, and finally model evaluation. And from that evaluation, we created our level 2 classifier engine. On the right, you can see some of the tools we used as part of our methodology: Pandas, scikit-learn, GenSim, and NLTK. Now for our data sources. Our primary data source was the Supreme Court cases provided to us by Digest. There were over 63,000 cases in that. We also had the law school syllabi and the revised penal code to help us create our criminal cases categories. And as you can see on the right, these are the 14 categories we came up with. For our data wrangling, what we mainly did was remove unnecessary variables. These were HTML tags, formatting tags, GR number, proper nouns, punctuations, stop words, duplicates, and headers. After that, we did tokenization and lemmatization.
All right. So after the data wrangling, the next thing that we did was to identify the keywords to be fed into the model. But before that, let's take a look first at the criminal cases by year. Our dataset included cases from 1901 to 2017, and 42% of which came from 1990 to 2010. Also, the year 2000 was the highest number of cases with 699, which was 4.6 times higher than the average of 151 cases per year. Now, let's move on to the keyword extraction. Here, we applied 4 approaches: topic modeling, syllabi, desk research, and consultation with the Digest team. And for us to apply the topic modeling in our EDA, we use 3 models, namely LDA, LSI, and HTP, wherein the LDI has the highest clearance score of 0.50 with 15 optimal number of topics. But during the EDA, we noticed that there's still lots of keyword noises in our models. And with this, we refer to the syllabi, we conducted desk research, and we consulted with the Digest team to come up with the final set of keywords. And it is also noteworthy to add that we explored these approaches for us to come up with the final list of keywords, which you will be seeing on the next slide.
So these are the list of keywords gotten from the EDA. These were the criminal categories that we saw from the EDA and from consultation, and these are the top keywords from those. We ran a script through the dataset using rule-based NLP to find those top keywords and label those criminal cases with categories that we took from the EDA.
Now that we have our case category labels, we move on to modeling. We trained 5 different multi-label classification models on our label dataset: ExcelNet, Roberta, BERT, Distilbert, and logistic regression. Then we used multi-label metrics from the scikit-learn package to compare their performance. Looking at all of our metrics, ExcelNet has the highest performance across the board, with a coverage error of 6.88, LRAP of 82.16, and label ranking loss of 12.11. Next. Shown here are the hyperparameters used in training our deep learning models, as well as the training time, which took well over 8 hours for all 4 models using our personal computers and Google Colab. The number of epochs was also limited by the storage requirement of each pass of the model on the dataset. So, to sum up, did we make law easier for our lawyers? We encountered many challenges along the way, but the predictions provided by our models for the cases in Digest Library have the potential to save clients valuable time in legal research. Still, our project may be finished, but there is more that can be done. With that, we move on to our recommendations. Our first recommendation is to involve the Digest team or other domain experts more in the labeling process. This can be achieved through consultations or through machine learning techniques such as active learning or weak supervision. Second, we recommend using additional computing resources when training the deep learning models. The dataset was quite large, even for Google Colab, so it is suggested to use computers with GPUs for training. Another approach that can be considered is text summarization and filtering the dataset. Third, the classification of other types of cases aside from criminal would be of great benefit to Digest. We would like to note, however, that a different labeling strategy must be developed depending on the nature of the cases under these types. A network analysis of case citations can also be employed to quantify the similarity of cases and build a recommender for Digest. Finally, we recommend the use of other machine learning models which are not implemented due to time constraints, such as Decision Tree, Random Forest, XGBoost, or others. And that concludes our presentation. Thank you very much, and we will now take your questions.
All right. Thank you so much, Team Digestion, for that presentation. And good evening, everyone. My name is Bash, and I will be your moderator for this evening. So again, for our audience, as seen in the chat, please feel free to head on over to the Dory link to send in your questions for the group. For now, I will be opening the floor to our panel of judges for their questions. Let's start first with Inigo. Inigo, any questions from our group?
Hi, yes. Evening, everyone. I do have a couple of questions. Actually, thank you guys to especially the organizers. Great idea that it's on YouTube. Well, it's on a pre-recorded, right? So I was able to see this beforehand, and I was able to prepare a couple of questions. But hats off to you guys, a great presentation. And yeah, really excited also. It's really great that you have the client here as well. So a plus point for that one, right? Number one question I have actually is more about clarifications in terms of just like the labeling and just like how you guys got your corpus and the data set, right? I think I recall in the slides you had like I think was it around some 68,000 cases. Were these all labeled? Like how do you guys get the ground truth labels? It's more like a clarification. Maybe I missed it in the presentation, but there's also a slide also about like the 18,000 NLP tag rule-based NLP tag. How could you explain how that's done a bit more?
Okay. For the 68,000, that is all the cases that we have. And from that 68,000, it was split into level 1, which is criminal, civil, and other categories. Afterwards, what we did, we got the civil cases, which was I think around 18,000, which we then classified to level 2.
Mm-hmm. And you guys, I remember seeing in a slide you applied sort of like you had an EDA where you looked at the top keywords, right? Was this the one that you sort of used to sort of make your ground truth labels?
Yes, we mainly touched the criminal cases because for the classifier, we only classified for level 2 the criminal cases.
Got it. Okay. Also, yeah, go ahead.
Oh, sorry. So actually, the choice to limit exclusively to criminal cases also came out of our consultations with the client. We asked Digest what would be most useful to lawyers to have classifications immediately. also keeping in mind that we only had 2 weeks to do our classification. So we picked up from previous work as presented by Duke. They already had the level 1 classifications, which is your general case labels, which is your civil, criminal, tax, and so on. So we pick up and do the level 2 labels. So criminal was chosen because based on our domain experts, which is to say Digest, they said that this would criminal cases were the most searched cases and the most useful for lawyers to have like more granular classifications. So we thought it would be the best place to start.
All right, thank you. My other questions are actually more on. I saw you had a slide around the metrics, right? Every time I sort of see slides on metrics, my main question is always like, what does it mean, I guess, for the end user or like the actual the client, right? So you use, I think, label ranking average precision, no? I think it's what you guys decided on with these models. Could you explain, like, maybe a bit of like intuition for those not familiar, and perhaps maybe more critically, why is this metric important, right? If you had to, I guess, like communicate it to Digest, right, in a simple manner, why is this a good metric that says your model is good?
Okay, so in general, so the three metrics we used are from the scikit-learn multi-label classification metrics package. It's really important. One really important aspect of our text classification is its multi-label. That what differentiates that from multi-class is the labels are not mutually exclusive. This is something that is very important when you think about the cases that we're looking at. There are a lot of overlaps. This was discussed to us by Digest. A given case can be, based on our categories, it can be 2 to 5 different categories. For example, a carnapping is both. A carnapping is both crime. If a carnapping ends up in an accident, so that's already a crime against property. It's also a quasi offense. Without going into more sordid examples, I hope I illustrated it. So label ranking average precision, that's the average of the ratio of true versus total labels with a lower score over each ground truth label assigned to each sample. So all 3 of our labels try to illustrate the coverage of the models in terms of how many true labels they can, which is an important distinction again from multi-class, because for multi-class you're looking at one versus rest classifications, which is kind of reductive, which is very reductive when you think about these cases. Yeah, because there's so many overlaps. We can't. It's important for lawyers to. We felt it was important for lawyers to know, and that this would be relevant to their legal research. So we use label ranking average precision because this captures the ratio of true label. The ratio of more than one true label. It captures value not just in the best label but also in the next best and so on. We actually did a brief preview for Digest and showed them the probabilities of our labels. One other metric for success we looked at but isn't featured here in the presentation is whether the top K accuracy, which is to say the accuracy of the top K labels, which in our case we would set to maybe 2 or 3. because that would be because of probably the top 2 or 3 labels are what Digest would need, what lawyers would need to be most correct for a specific case. Yeah.
Got it. Thank you, Ben. I have one final question. Hopefully you can squeeze this in. So going back, I guess, into like the sort of the metrics here, right? Is there like a baseline that you guys have, like what's the most naive, I guess, implementation that I guess could be as like a baseline, and how well does this model improve on that? Is that something that you guys explored?
We did try to do some research. Unfortunately, we couldn't find like a real baseline that's comparable to our. So I guess that would be one recommendation we would give to the next groups who will pursue our project with Digest, is to to maybe base on I guess the most baseline we have is the previous group's work. I don't recall the figures for their metrics right now. But I do recall discussing with Caleb and Julia, and they did mention that our labels, that our models reached comparable numbers. Yeah.
Nice. Yeah, that's all my questions. I would like to leave also to Michelle also if you have questions.
All right. Thank you so much, Inigo, for those questions. Let's go ahead and entertain Michelle's question. Michelle, any questions for the team?
Yeah. Yes. So first of all, good job, guys. It seems like a very promising app, but taking off from what Inigo just started asking about, no, in terms of how much better is it? So going back to your main question, how much easier did you make the lawmakers' lives? How much more easier is that? Much easier is that, diba? Not just looking at the models, no, based on the models, but remember here that you are trying to replace searching via Google, right? That's how they do it now. So yun lang, super simple. How much more convenient is that? Because if I type in a few words in Google, how much faster is that versus going to your app and getting the results that I want? Have you done that comparison?
Yeah, that one we can actually answer from experience. So in the process of trying to get ground truth labels for our models, we had to do searching of our own for cases, and I will tell you, it's very hard. It takes the classification numbers for cases are very confusing. There are several kinds: general register number, Supreme Court reports annotated, a few other different, like 3 other acronyms I don't even remember right now. These are all different numbering. These are all different numbering systems for court cases. And unless you have access to a paid law library, it's very difficult to get reliable. It's very difficult to get reliable sources for these cases. And you would think, for like national, for like gigantic institutional laws like the revised penal code, upon which we based our criminal case categories, we had problems looking for the revised penal code, and when we consulted with Digest, like about where to get it, they gave us a source, but they also qualified it may not be updated because the revised penal code is it's the revised penal code of 1930, and it is the same document revised again and again, but there seems to be no centralized legal repository. So I would say, based on personal experience, all of my group mates can attest to this. We save lawyers hours by going through it ourselves.
Yeah, I would say that's how you should build up the story, diba, at the start. So I did remember your statistics on, how many documents there are since the 19 something something, diba? But then you saw a lot of parang they picked up, no? The number picked up in the around 1950s and so on. So I thought you were gonna use that. There's an angle to that, and that you're gonna use in your study measured. Sorry, my internet is lagging. So for me, I would. It's more of a suggestion to move forward. The measure of success, I guess, that you should be aiming for is how much more convenient is it going to be. Now, the value proposition needs to be highlighted versus how they're doing things now. So if it's take that data, do a time and motion, interview your clients who are here, and do a parallel test. I'm sure you do like a UAT or something, and then jot down the numbers. How much better are your results in terms of relevance? Of course, not just the speed of the search, right? And then it's really a pain to get this out, and really having everyone using it, diba? If they have Google anyway to fall back on. So you have to manage that change, and managing that change means showing these numbers, no? You have more time to actually do legal work than search, than doing just searching, no? And that's really a good value proposition.
Can I
Yeah,
clarify
good start.
on that? With regards to versus Google search, when we tried searching it on Google, what would come out was, let's say you're looking for a murder case. You'll probably get 1 or 2 or 3 famous murder cases. But based on how Google's algorithm works, it won't really give you like all of them there. So I think like when searching multiple cases, when you want to see like a lot of cases, it becomes like a lot better than Google, because it will give you like a huge amount of murder cases. Whereas if you're a lawyer, you can find something similar. Because what Google gives you is the most famous, which is probably something as a lawyer you might already know, right? Because if it is the one that everyone knows of, it might not be something that you need to know because you already know it.
Yeah, that's the value. And so I also want to ask why you thought of, because you mentioned it's a limitation, and no one is a legal expert or no one is practicing law in the team, but why did you choose this topic or this domain?
Because I want, speaking for myself, I wanted to try something with the NLP, and this was the NLP project that was out there.
That was my hunch, actually. So you wanted to to use your newfound skills from Eskwelabs, and this was a good use case. I agree. Don't get me wrong. I agree, and I fully support. I hope that our legal system can have this kind of tool. But and maybe I'm biased, but this is what I teach in the masters. No, it's domain understanding, how very very important it is in data science projects. So just the labeling alone, right? Maybe you don't have to do it yourselves, but the exact person who can help you do it faster, based on their years and years of experience. And then how does it get deployed? Need to right now. So yeah, I encourage you to develop it further, but siguro yun lang, it would be ideal, as you said, that's your next step, number 1, which is to consult with a domain expert. Yeah. That's it for me. Thank you.
All right, thank you so much, Michelle, and thanks for questions.
Sorry,
and
Bash. I do have one thing that may I, if I, hello, can you hear me?
Yeah, sure. One last question.
One last, sorry, if I may, because well, I have a sort of experienced this similar kind of problem at work, right? So Michelle is definitely right that the metric for like just timing it with like someone is ideal, but of course as data scientists we can't actually have that. So what might be a good proxy in the meantime? I think you guys were pretty good with using average precision at K. I think in information retrieval, especially with Google search, that's exactly what they use, right? To figure out like how to get to the like the best search results for you guys, right? So what you could do maybe as a suggestion, right, is the two. So my question before was about baselines, right? Two baselines you can do in this space would be one, just like a sort of random strategy where just like throw a scatter shot, right? How much better is it from that strategy, right? Naive strategy, but it's a good baseline. Second strategy you could apply here would be again, popular strategy. In other words, just get like the most search results and then return that for your sort of queries. Just like how much better does it perform beyond that, right? So you can imagine like at the output of that would be average precision at K sort of curve, right? So the x-axis would be like the K, how many sort of parts of the search are you looking through, and then you have three curves would be like the model that you have. Ideally, it should be higher over the two naive strategies, which would be popular and random, right? So that might be a way that you can demonstrate it. So then once you have that, you can sort of have a headline to your stakeholders saying like, within the top three cases, I can achieve, let's say 50% precision, which is twice as higher than if I did it with like a naive approach, right? So that's a soundbite that you can use to sort of demonstrate value for your sort of system. So just a suggestion.
Thanks so much, Inigo, for those suggestions, and thank you for plugging information theory. I think that's another thing that we can really like explore on how we can improve our methodologies in analytics in the country. Unfortunately, that's all the time that we have for the Q&A for this group. Again, there's so many questions that our audience also asked in our Dory link. So please continue typing your questions in the Dory link, and our fellows will comment on those and answer some of those items later. And again, thank you for those who have already sent these questions. Moving on, I would like to introduce our second group of fellows with their project, Pedro, Protecting Everyday Rated Online Trading for Filipinos. Please welcome Rowan, Iral, John Marco, Francisco, Joshua Miguel, Bernardino, and Robbie Pombo. Take it away, guys.
Good day, everyone. Today, we'll be presenting to you our model-based trading application. Looking at the market, we have a lot of apps around. And one of it for the forex trading market is the MetaTrader, the TradingView, and eToro. But these trading apps does a lot for us. It helps us provide with the technical indicators we need. It helps us place orders. It helps us also to monitor the trades and be able to see the price action that we are experiencing in the market. It can also give us news feeds. However, it's hard to learn trading alone. You have to learn fundamental analysis, which is understanding the news, technical analysis, where you have to understand the different jargons and other tools to be able to see the charts. We also need to understand the sentiment of the market, how they feel about a certain company or trade. And at last, we need to have the trading psychology to be able to trade the market.
But what if we had a way to make trading more beginner-friendly? The main issue is that time is consumed on just learning. Here we have created a platform that synthesizes the indicators. This reduces the time needed to learn the fundamentals. But before we dive in, let us first take a look at our methodology. For data extraction, we use the trading platform API from MetaTrader 4. Afterwards, we prepared the data by resampling for model inputting and feature engineering. We then trained multiple models and tuned necessary parameters. Lastly, we deployed the application with the best performing models. We used the trading platform API to extract a time series dataset containing the basic price indicators for Forex, such as open and close prices, as well as the volume. The technical indicators used were based on the trading strategy manual, Beat the Market Maker by Steve Mauro. Afterwards, we consulted with an experienced Forex trader to narrow down the indicators selected. As examples, here are some of the different indicators used for modeling. For the trend indicator, we use ADX or average directional index, which is used to determine when the price is trending strongly.
Further, for our modeling workflow, first we prepared data via a train test split scaling and cross-validation. Then next, we optimize the best model via grid search of different model parameters. Then afterwards, we compared multiple models including a time series-based model and a deep learning model. And lastly, we evaluated the model performance via several metrics as shown in the screen. To find the best features for modeling, we use F-regression score to calculate the weight of each indicator and selected the highest ones. On the left is the correct use, while on the right is the TDI, the Trader's Dynamic Index. We trained several machine learning models. Here, the model performances are evaluated using R-squared score, mean absolute error, and root mean square error. We also compared the models with the naive forecast, a baseline model used in the forecasting Forex prices. This is the prediction of ridge regression, which is the chosen model in our project.
So for our conclusion, for our ridge regression, it had the most optimal metrics evaluation, and it beats the naive forecast. The pipeline that we also created can also be used for navigating different financial instruments like cryptocurrencies and stocks. The only thing that has to be changed is the data source. And lastly, these models are only applicable for next period predictions only. As recommendations for similar studies in the future, we highly recommend that they explore other models such as FD Profit, which is another time series model, and MLP and CNN, which are neural networks. There also needs to be a focus on time series modeling for multiple days predictions. And lastly, there has to be a performance on backtesting to compute predicted profit and loss. And to give a demonstration on the applications, we will now go to our first output, which is the Discord bot. All right. So for our demonstration, we have here our Discord bot. And to get started, let's look at the different commands. To look at the commands available, we'll use help. And over here, we have 5 different commands, including the help command. So we have graph, which generates a candlestick graph for the latest data. In particular, we have a recent time period that will be illustrated via a candlestick. Predict 1 predicts the next period prediction. For instance, if you wanted to predict 1 day ahead for the prices, it'll predict 1 day ahead. And predict 5 is similar, and the only difference is that it will predict the next 5 periods instead. And for the table function, it will generate the latest 10 outputs from the price that you want to explore. And if you want to learn how to use these different commands, all we have to do is look at help and then type the another command that you want to look at. For instance, let's say you wanted to look at graph. And then it will generate the commands needed and a description as well. All right. So here we have the graph. How to do that? We have to type in exclamation point graph, the instruments. In this case, we want to work with Forex data. The pair, there are 4 available pairs in our application. And lastly, TF, which is the time frame, which could either be daily, weekly, or hourly data. In this case, let's say you wanted to graph the Forex pair Euro USD, US dollars, and you want to look at the daily data. So all you have to do is type in graph Forex USD D1, and then you will see the actual graph. And now let's say you wanted to predict what would the next values be. In this case, let's type in predict 1. And let's say you wanted to predict Forex Euro USD. And let's say you wanted to look at weekly data. And then right here, you can actually see that the model outputted the current price as well as the next possible price. In this case, we have two different models that are used for the application that will predict the next possible values. And lastly, if you want to look at the table of the last previous values, let's say you want to type in exclamation point table forex, and you wanted to look at, let's say, USD JPY, Japan versus USD. And let's say you wanted to look at the hourly data, and there we have a table of values for the recent prices of the pair. So that's it. You feel free to use this as well. And we'll now hand the floor to the Streamlit application.
So now here's our Streamlit app. Our Streamlit app is created using the models that we have studied. We also have here our Discord server link and our presentation. If you look at the chart, you will be able to see our candlesticks. For example, for Euro USD at hourly period, you could see it here. You could also adjust the number of months you want to view. For example, I want to reduce it. And then there are also tables at the bottom, which shows the last 10 entries points of the certain instrument that you are looking at. We could also click on the EMAs to have it graph on the candlestick. This chart is also interactive if you wanted to zoom in. These are the basic functions that we have for this portion of the app. So if you want to zoom in and check some of details, you could see the candlestick. At the top of the portion of the app is the last 10 entries with its indicators. The next part of the app is showing us the predictor A and predictor B and will give you the next price. And at the bottom is the chart showing the estimated price point in the next 5 periods. For example, in this case, it is hourly. We also have a pilot monitor if the MetaTrader platform is still communicating with our app. If there are open trades, it will also show us the open trades that the robot is currently doing. I hope you enjoy our presentation. Always go and check our link at this QR code. Thank you.
All right. Thank you so much, Team Pedro, for that presentation. Again, for our audience, as mentioned in the chat, please feel free to head on over to the Dory link to send in your inquiries for the group, and we will answer this during the Q&A or reply directly to them after. Now it's time for the second round of Q&A for our fellows. Again, let's start with Inigo. Any questions from you?
Yeah, okay. First off, good stuff, guys. What sort of comes to me is that you guys really shine with the engineering part of it. So great work on the bots. I do have a question. So I was sort of shocked when I saw like that one slide where you guys have such a really good fit of the model, right? So my initial thought was like, you guys are going to be rich. So could you tell me a bit more? Like, whenever I see something like that, it's always for me too good to be true, right? Are we comfortable with that metric, or should we look at it again? So I'm referring to the ridge regression model, right? So I think they had like a 0.99 or so, and like the curve was extremely close to it, right? Yeah.
Well, based from the model prediction, the evaluation, the model evaluation metrics that we use are based from previous studies. They are what we usually use on time series modeling in evaluating data. So that's where what we base on in evaluating which is the best model. However, I guess what we weren't able to do because due to lack of time, because we were just given 2 weeks to do this, was the profit loss metric, the profitability accuracy, which is, I guess, the most important part, because that's where it will determine if you will get rich or not. So I think what we just settle on is the price prediction only. But we believe that the better metric is the profitability, which I think was backtesting is needed in order to determine how profitable our model will be.
Though I would sort of potentially challenge that. If you did perfectly know the markets, you could time the market, right? In other words, if I know like the next hour that it'll go up, right? I'm gonna put money in it and then exit the next hour, right? It's so what strikes me is maybe you guys have stumbled on a model that either you've made like an extremely huge money making machine with this model, or maybe something's up. My bet is something. It's more in the latter. I'm just wondering if you guys have hypotheses around whether this is too good to be true, or like you guys really think this model, this ridge regression model, really forecast the model that well.
Actually, that's one of our previous that's what we're wondering while we're doing the project, because we found out that it's too good to be true. So I think I think that's where we're looking for, why it has a high accuracy as compared to other models. So yeah, I think what we decide on is that in order to be ensured that this model has high accuracy, we employ as well the backtesting on that. And yeah.
All right. Yeah. Maybe just curious about you showed the methodology, right? So you had the train test split and then like the metric. So this 1 hour prediction, right? And I just want to understand if I get the sort of modeling setup correct, right? What we have here are the price movements, right? For hour one, let's say T, and you're predicting T plus 1 hour, right? For the price movement of that currency pair. And part of that would be the features that belong to all these different technical indicators that you showed, and you applied ridge regression on that. So it's like basically all these different indicators through this sort of ridge regression model to predict T plus 1H. Is that correct?
Sorry again.
Hello, sorry. Yeah, would you want me to repeat? Yeah. Okay.
Sorry, can you repeat again the question?
Yeah. Okay. So imagine like you had like a table, right? This table for one row that we have is a price pair with the different technical indicators as of that hour, right? So that's your row, right? And so what you're predicting would be, I guess, your y hat, or the thing you're going to predict is the price movement as of the next hour. Is that right? Yeah. And so then what you did is like with all of that, you ran a ridge regression model.
Yes.
Okay, got it. So yeah, thanks for clarifying. I just trying to imagine how it could be that good. That's really something that's on my mind. But yeah, I'll leave it at that. Michelle, maybe you have the questions.
Maybe we can also check. Yeah, what was the scope of the data set that you used for this? And was it up to the recent mga tradings? How recent was the data set, siguro? Okay. Did it have any effect of the pandemic?
Okay. Rowan, can you answer?
The recent one, we use the standard recency, like 6 months of data and up to a year for 2 years for the weekly data. That's how we decided on using the recency. So yeah, we select those recency values or the number of days. So we computed it on the number of days most of the time. Yeah.
So that's 2020, 2021 data.
20.
Yeah.
Starting from 2021. Yeah.
Okay.
And we backtrack it.
Okay. And then the train set was 80-20, no? Train test was 80-20 on the 2020 data set.
Actually, to add on what Rowan had answered, for the hourly data, our training set is 6 months. our full data set is 6 months, so it's 2021 per se, because the last date of our data set is July 28 before as of last week, July 28, 2021. So minus 6 months is our whole data set for H1, then 1 year for D1, and 2 years for W1 for week 1 for weekly. Yeah. So our data set ranges from 2018, I guess, or 2019 up to the latest.
Wow, and still very, very good performance, no?
Yeah.
Even with okay. Sige. I wanted to ask also who the target users are for this app. Say you were showing something on Discord and you were showing something on the Streamlit app.
Okay. Miggy, Robbie?
It's for the beginner traders. They're just our target market is for traders who are just starting out.
And you parang based on your generation or on a study that Discord is the new Facebook. I don't know, I'm too outdated pero
Yeah, I think gamers.
Why did you choose?
Yeah. It's the new market. It's the new hotspot. Gamers, a community, people who are very active in their community, like data science, Kaggle. There's a recent activity now in Kaggle, which is 30-day ML, machine learning, and they put their community in Discord. It's very active. So yeah, Discord is the next hotspot when it's come to social media.
Okay. So ano siguro, I'm not familiar obviously with that kind of environment, but what makes your app unique? Kasi there's so many trading apps out there, no? Is it more you bank on the accuracy of the models as you have just demonstrated? Is it more, I don't know if there are other apps that are catering towards the beginners. I think there are. So what are you hoping for, kumbaga, in this particular app? Is it there's something unique ba? Kumbaga, maybe that's what I'm asking.
I don't know if I get your question yet, right, ma'am? But when we were discussing our this project, this analysis, our mentor, Sir JC, raised one concern. He said that what our advantages, what is our edge? Kasi madami ng existing. For me, he used the word synthesize. We will focus on just the indicators, the technical indicators. We will not try to cater everything because it's overwhelming. So we will just use the indicators presented, the selected, which is consulted by our friend, Rowan's friend. We consulted the indicators used. So yeah, I hope I get your question.
Yeah, okay. Thank you.
All right. Thank you for the question, Michelle and Inigo. Any question from Aurelian?
So I have a question from the audience. How does your model adjust to current happening and economic impact?
Okay, so since the limitation of our model, it's more on the technical analysis. It's dwelling more on the technical analysis side, which is based on the trends of the numbers itself. I guess for the current events or economic impact, I guess it's for the next presenter, the sentimental analysis.
Yes.
Yeah. So that's where the current impact will be incorporated, but ours is just for the regular trends and for the movement of the numbers per se. So
we are for the numbers.
Yeah, we just the prediction is based from the numbers, but for the sentiment of the people or current news,
from the news,
it would be tackled by the next group.
which is heavy.
Yeah.
Cool, fantastic. All right, so I won't quiz you on, I guess, the economic conditions that may cause certain types of technical analyses to be more or less relevant. But when you were doing this project, what were some of the traps or potential, pitfalls that you were particularly aware of and didn't want to fall into while designing your forecasting model?
Okay. So, Rowan, the disclaimer. Okay.
Hello.
And the disclaimer. Yeah, we usually focus on the disclaimer because it's still up to the trader's discretion if he will take the trade or not. But as much as possible, we try to also retrain the model that we have on some sort of periodic training, so it gets updated as the market also changes.
Cool. That's definitely agree. No liability. You guys are not constituting financial advice, but yeah, no, that's great that you're also looking at making sure you're not overfitting to this particular market moment right now.
Yeah.
Yes.
Well, that's all for me.
All right. Thank you so much, Aurelian, for giving the questions from our audience. And thank you again to those who sent over these questions. And to our second group, don't worry if your questions were not answered. Our fellows will be reading through your comments and answering your questions through the Dory link that we provided. Moving on, I would like to introduce our final capstone project of the night. Please give a warm welcome to Sean Ong, Adrian Genevieve, Janairo, Adam Zhu, and Nili Pantino for Mercury.io, the stock messenger. Take it away, guys.
Hey everyone, we are proud to introduce to you Mercury.io, your very own stock messenger. With the ongoing pandemic, more and more people are venturing to the stock market to invest their funds. So what are you waiting for? Today, we will pitch to you why this topic is relevant, our general methodology for creating a recommendation model that addresses previous areas of improvement, and a summary of our main findings with ways to continue our platform moving forward. But first of all, why do we care about this topic at all? Well, an old Wall Street saying states that financial markets are driven by two powerful emotions, greed and fear. We can see the proof of this in history. From the panic sells in the financial crisis to the bullish trends in cryptocurrency and meme stocks, we even may be guilty to this presence. We all have the feeling of wanting more and not knowing when to stop, but also being too afraid to get on in the first place. After all, this process isn't easy at all. Far too many people spend too much time and effort doing research to knowing what stock they want to invest in. For one, the internet and social media has way too many bits of news, some that even contrast with each other. Even attempting to start means hours wasted. We call this analysis paralysis. That's why we have created Mercury.io, to simplify the process. Specifically, we analyze the news sentiments of a given stock, as well as its price over time on the general market to draw conclusions on whether one should buy, hold, or sell the stocks. We look at both the retail investor and fund manager point of view. In summary, we know that markets are mainly driven by investor emotions, as Ko has suggested. This is where we look at news and social media sites to look at what these emotions entail. Though there are many stock recommendation systems out there are not many that cover the emotion component. With NLP, we can quantify sentiment in a context that determines specific boundaries of whether a stock should go up or down, and we compare these sentiment quantified values to the actual stock prices as a means of an accuracy metric.
So how do we exactly quantify use sentiment? This question can be answered by using natural language processing, or NLP. First, we gather data through web scraping from various news sources that Filipino investors typically use. We then pre-process the gathered text data, manually read and labeled a sample of the articles to compare with NLP dictionary's results, and selected the dictionary which has the highest accuracy. Selected dictionary is then used to score our entire news article dataset. So we have scraped about 24,000 plus articles from Twitter, Instagrams, Business World, Manila Bulletin, and Enquirer. For Twitter, we used a scraping tool called Twint and focused on formal business accounts. For Instagrams, because login was required, we used Selenium to automate logging in and browser navigation. To parse through the article data that we need, we used Beautiful Soup and Newspaper 3K Python libraries. Twitter and Instagrams had the most data given that they churn out multiple tweets and posts per day. To pre-process our text, we tagged the stock mentioned in the title. We made the text lowercase. We fixed contractions. We removed punctuation, numbers, and stop words such as the, an, and in. And we exclude not in the stop words list because negation is important for the context of our articles. And then finally, we tokenize the text, splitting the entire article body into words. After pre-processing the text, we move on to sentiment scoring of the articles. We first manually read and labeled a random sample of 400 articles and checked which among the 4 dictionaries, Vader, TextBlob, Learn MacDonald, and Harvard 4 matched our labels. Learn MacDonald scored the highest in accuracy, matching 59% of our manual labels. This dictionary was built on US SEC 10K documents covering financial performance and company disclosures. This is domain specific and appropriate for finance topics.
At this point, we have the sentiment scores, number of articles per day, and the closing prices of the stocks and PSEI. With this, we were able to get our inputs such as the percentage of positive sentiments, mean sentiment scores, stock normalized close using the standard scaler, normalized PSEI close prices, and our target variable, which is the movement of the price after 5 days, classified as up, down, and stay. These are our inputs in the models KNN and SVM. And the output is our recommendation of the possible movement of the price for the next 5 days. We define the percentage of positive sentiment as the number of positive articles divided by the total number of articles in that day, and the mean score as the average sentiment score in a day. This is a part of the time series plot of Globe's stock prices and mean sentiment scores, where the closing prices shows an uptrend and sideways movement. With the sentiment scores in this period, we can see at the histogram on the right that more of it is at the positive polarity greater than 0. An example of the headlines in this period are Globe's partnership with Pure Gold at the Negosyo Convention 2019 and Globe's partnership with CPPI to provide online solutions to pawn shops. With the downtrend period of BPI's time series plot of closing price and mean sentiment scores, the distribution of sentiments at the right is more of the negative polarity, less than 0. This includes articles such as BPI being entangled with the alleged disappearance of money from German payments firm Wirecard, and tweets saying that BPI net income was down due to COVID-19. For our classification, we consider the number of trading days in our country, which is 5 days. The movement is up if the price change after 5 days is greater than 1%, down if the change is less than negative 1%, and stay if the price is within the negative 1 to 1% range.
Another feature we engineered is the normalized price movement. This is computed for by subtracting the percent change of the price of the index from the percent change of the stock price so that we can isolate the stock movement itself, ignoring the effect of the market. As for our results, we decided to follow the research papers in segregating our movement into 3 categories, namely up, or when the stock price goes up, down, when the stock price goes down, or stay when the stock valuation change is less than 1%. We can see that our results for Globe are on par with the benchmarks from the papers we have read. We further experimented with reducing the classes into only 2, where the increase has to go above 1% for the movement to be considered up. This is factoring in the brokerage fees and tax which increases the cost of the stock for the buyer. We can see that with Globe, KNN 2 categories is the best for predicting downward movement, and SVM with 3 categories is the best for predicting upward movement. As for BPI, it is also within the benchmark, with KNN with 2 features being the best in predicting downward movement and is also the best for predicting upward movement. In conclusion, we used the Lauren McDonald Finance Corpora as it yielded the highest accuracy in labeling news sentiment. It is best to predict downward movement for Globe with SVM with 3 classes, and the best to predict upward movement with KNN with 2 classes. As for BPI, it is best to predict downward and upward movement with KNN with 2 classes. Given the precision, our model accuracy is also competitive with those in the research papers we have read. Given the promising results of our classification models, Mercury.io can be offered as a data product for both retail and institutional investors alike. As for our recommendation, we plan to further improve the features we use by engineering more and see how they interact with the model. We also plan to integrate technical analysis, as news aren't the only drivers for stock prices. We also have only used 2 stocks for the meantime, and we plan to create models for more stocks. Finally, after improving the model, we can market Mercury.io as a data product for both retail and institutional investors alike. Thank you for listening. Do you have any questions?
All right, give it up for our last group of the night, Team Mercury.io. Thank you so much for that presentation. We will now start with our Q&A segment with our panel, and if we have time, take a few questions from the audience from the Dory link. The floor is now open for the final round of Q&A from our panel of judges. Inigo, wanna go ahead first?
Sure. Great presentation, guys. It's a common theme, I guess, that we can apply data science to the financial markets, right? So it's also a common one to try NLP, right? So quite a lot of these use cases out there. I do have 5 questions here, right? You had a slide about interpreting, the classifier results, right? You had accuracy, precision, recall. If you had to translate it though to, let's say, an investor using your product, what do you mean by a 64% accuracy exactly? Like, what does it mean to me if I wanted to invest in your product?
I guess from a business standpoint, we can compare this metric to existing benchmarks as you see on the right-hand side. And for a completely random guess, that would be at around 33.3%, just because of the different ones going either choosing between down, up, or stay. And so I guess from that standpoint, it's twice more effective than simply choosing a random guess. And I guess if you were to compare this to other existing metrics, we can say like our model is this much better than the ones existing out there. And you can see the values on the right-hand side.
Right. Though my question is more around like the actual, I guess, semantics of when you say 65%, like what exactly is the denominator, right? Or yeah.
Accuracy is basically how well it is able to predict whether it goes up or goes down, the overall score of the prediction. However, we can see the weakness of accuracy is that in imbalanced data sets, like for example, more than like 70% of your data is all down. So if you just predict down all the time, you'd get 70% accuracy. So that's why we also took a look at precision and recall. Precision means that, for example, up, let's say it says a 66% accuracy, precision in up, it means that 66% of those predicted to go up actually went up. Whereas for recall, it means that it was able to capture like 38% of the up. We believe that even though the recall is kind of low, it's still acceptable because in the financial market, it's impossible to capture all upward movements. But what is important is you are able to capture the upward movements. And we see precision as more accurate because when the model tells you, okay, the stock will go up, you want it to go up. So even if it doesn't capture all the upward movements, but it is able to capture some of them, and we're able to benefit most of the time with that prediction, I think that would be good.
Got it. Thank you, Sean. Curious though, like specifically in here, when you say, let's say 66% of the time will go up, do you have like a time horizon in mind when you say that metric? Like, will it be 66% in the next 30 days or until? Sorry, Fred.
We set it to 5 days since that's more or less the weekly. That's more or less a stock market week here in the Philippines, where the market is open for 5 days a week. So we're predicting the trend in the next 5 days.
Right. So what you're saying is, like, to the investor is like, I can predict with you with sort of 65% accuracy in the next 5 days, it'll go up or down, right? Basically.
Oh yes, but I believe that precision would be the better metric.
Right. So if I recommend you like whatever recommendations, I'll be right 2/3 of the time. Basically,
yes.
Right.
Yes.
Got it. Thank you. Second question out of 5. Curious about back testing, right? So it was also mentioned before about like what potentially might be the returns of this, right? Is that something you guys might have explored? Like, it's one thing to sort of show that, yeah, maybe I'm right 55% or whatever percent of the time, but the magnitude is also important, right? So if I were an investor, what kind of returns might I be expecting from this kind of model?
We haven't done that yet due to the lack of time, but we believe that's something we can do going down the road. But we did define up as going up for more than 1% increase.
Got it. Okay. All right. Third question I have. So what I like about yours is, again, that the kind of twist that you guys have is the NLP side of things, right? It's a whole sort of different pipeline that you guys built out, which is pretty cool, right? I like that you guys were able to, use Twitter and like Instagrams and different news sites, right? I'm curious, and you also embedded it, or like your features were NLP plus the price movements, right? Is there a way to sort of see what's the incremental benefit of using text data, right? Like, how is it, like, if I just use, let's say, the price movements, right? Just like, I guess potentially what the previous group did, right? What lift can we expect, right, from using NLP here?
I could answer that. So, for our own value proposition, so investors usually take into consideration two analysis tools. So one is technical and the other is fundamental analysis. And there is, however, another common tool that they use, which is news. And based on my own personal and professional experience, I've worked as a stockbroker before, and what we would do on a daily basis is gather all news that we've read overnight, and then from there we get ready for the upcoming market open. And so that usually takes up a lot of time as well, and it may cause some type of analysis paralysis, if you will, for us in the trading room. So the NLP part of our project would definitely help in speeding up that process of decision making and also quantifying objectively what the news in the markets entail.
All right, thank you, Nelly. So the last two questions I have. Fourth question I have is about more of like an NLP thing, right? When you guys scrape the data, I'd imagine Twitter was part of it, right? Actually, a bit of two questions, sub questions here. How do you guys handle, for example, like, were there instances where there were, let's say, mixed English or Tagalog emojis or whatnot? Like, are those things that were included, I guess, in your NLP pre-processing?
For Twitter, as of the moment of this project, we only scrape the quote-unquote credible sources. So these are figures in the stock market, like people, like, these are the guests. So we have the PSE itself, then some brokers, then some influential people like Michelle Diong from ABS-CBN, then April Litan from Call Financial. So these are the quote-unquote credible people that we scrape from. So we believe that we haven't really encountered the mixed Tagalog and English yet.
Okay, got it. Final question. Not really data science related, but more branding. Why the name Mercury.io?
Hi. So we came with this upon a whim. So I was thinking of a name for this product, and I just remembered that Mercury was the Greek god of communication as well as finance. So that fit perfectly with the context of our project.
All right, cool. Because I did try to type up Mercury.io. It was a different website, but I just wanted to see if that was you guys. But yeah, those are all my questions. Thank you guys. Thank you.
Okay. And some questions. Did you find that Filipinos are more emotional when making investment decisions? Meaning it is a big factor, no? Looking at the sentiment, it influences their decisions.
I believe we couldn't say for sure yet since we haven't really scraped the public data yet. It was mostly the stock market authorities, which are these ones over here. So we couldn't say for sure. And we also don't have the metrics of foreign countries, so we don't have a comparison point.
I thought you were looking at related literature as to how sentiment has been affecting the stock prices. Didn't you, or I misheard?
Based on the results that we got, so with the slide on the results, so what we have on the right side is one of the studies we read up on, and this was more of the US market. So this is the US market. And from this, it's more of a 30 to 50 range in terms of accuracy. So it's sentiment doesn't necessarily affect the markets there. I mean, it's not a strong indicator, but with our results, it's I would say more on if sentiment has a slightly higher effect on movements in stock prices.
That was your problem statement, right? Or can you go back to your problem statement? And what was the answer to that? You're saying that you're not just recommending an easier way of doing the analysis, right? Rather, you want to make it more holistic by including also the sentiment. So did you prove that you have to impute sentiment when making the decision?
I feel from an intuitive standpoint, this does make sense. Like if you look at the previous group, for example, there are external factors that can't be really considered into a technical model. So it'd be also really interesting to see how these two models could somehow be integrated together to both to consider sentiment as well as technical analysis. Because I think the aspect that we're missing here is the technical side, and we weren't able to do that due to lack of time. But I think that would also help our accuracy metrics in respect to that.
I think it's tricky when looking at sentiment, right? Because I've seen other names right? In terms of, let's say, the impact of bad press on a particular let's say, I don't know if you're already born when this came out, but the chicken sand, diba? Na, na news before, I don't know, I don't remember anymore. But does that still have an effect? Obviously not, no, because there's much more bad press nowadays. But it's hard to isolate the effects of previous, bad press, and looking at also, so let's say BPI family, BPI savings, and other brands of BPI. Will that affect also the
I'm not sure if Michelle, we lost Michelle or just me.
Yeah, I think Michelle may be disconnected.
Right. So I think we can wait for Michelle, but while waiting, we can try to entertain one question from you, Aurelian.
Yeah, I mean, I guess I think Michelle was actually opening up a really interesting point. If you go back to your model evaluation, I would actually be very curious how much the difference between your performance and the benchmark is because of your modeling versus if it's actually that the benchmark reflects a market that is much less driven by, I guess, like the kind of sentiments that you were able to analyze. Versus maybe, yeah, if you don't mind going to the slide with your benchmark. So yeah, how much of this difference between, I guess, your US-based benchmarks, which kind of cap out at 55%, versus your highest performing model is at 65%. If we had a benchmark for the Philippines, it would be really interesting if as Michelle questioned, maybe it's actually that we expect accuracy to be much higher in the Philippines if this is a market where it is more driven by, or it's easier to predict based on user sentiment. Yeah, I think, yeah, I don't really have any other questions other than where were you guys in January? If you could have done this for Reddit comments, I would have been very appreciative.
All right, Michelle typed her question in chat. So the question goes, how will you isolate the sentiment unrelated products or brands to the company?
To answer the question, I think okay. We haven't yet touched on that. And another thing that we would like to add in our feature engineering is to classify the use. So maybe in that way we could isolate the products and the brands from the companies. And we could also check how each category of news can affect the price movement in terms of time of effect.
All right, so it goes as a recommendation then. Okay. So unfortunately, that's all the time that we have for Q&A. Again, thank you for those questions. Thank you for our panels, for those people and audience who typed in Dory their questions. Don't worry if your questions were not answered. Our fellows will be reading through your comments and try to answer those questions through the Dory link. All right. So I think before we close the night, the Eskwelabs team has sent over a short feedback form and launched a Zoom poll for us as well. for our comments and feedback. In Eskwelabs, we take your feedback very seriously, and we will use this to improve our events in the future. So similar to the negative feedback loops that we have in machine learning and transfer functions, we do the same and teach what we preach. So we value your thoughts and time, and that is why those who will answer the feedback form will receive an exclusive 50% off in our RL Plus. So you can get your promo code on the confirmation page of the submitted Google form. All right. So now to close us off, I'll be handing the floor to Aurelian, our COO and co-founder. Aurelian?
Perfect. Thank you, Bash. And thank you, everyone. On behalf of the Eskwelabs team, I want to thank you all for joining us tonight. I want to give special thanks to our guest speakers, the panel of judges, as well as our Digest representatives. And of course, a big round of applause to our fellows for all the hard work that they have been doing to turn around these projects in, wow, 2 weeks, so short, but yet such interesting and inspiring results. I really hope to see you all again tomorrow for our day 2. Our guest speakers tomorrow will be JT Solis and Joseph Amara from the Mayani startup, which is a tech company that focuses on linking smallholder farmers and their agricultural products to buyers through an e-commerce platform, very relevant in these times. And you're also going to notice tomorrow's projects are going to focus on agriculture and healthcare. So those are tomorrow's 3 projects. And of course, for those who have seen this and are interested in applying for the next Data Science Fellowship, you can feel free to head on to the links that are sent in the chat for the next cohort, which is slated for November 15th. So today was a big day for the stock market and lawyers, right? Lawyers and bankers, that's an interesting group. Tomorrow is going to be doctors and farmers. So have a good evening, everyone.